Chemistry lessons. Chemical bonding. Ionic. An ionic bond is a bond between a metal and a nonmetal. If we take a look at the periodic table here, we will notice that all of these green elements are all metals. These elements here that are listed in blue are called metalloids. They have properties of metals and nonmetals, and for our purpose we're going to consider them metals also. So there's a big heavy box, stair-step ladder if you will, that comes down here, and we're going to call this little area right here in this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements are the only ones that we're going to consider non-metals. Okay? So remember, an ionic bond is between a metal and these non-metals. That's what an ionic is. Now, metals are always positively charged, and we call those cations. Non-metals are usually negatively charged, and they are called anions. When we're naming something and we're writing it down either in the compound or the name, the metal always is listed first, always. So if you see something where the non-metal is listed first because it gives you two elements and tells you now you need to try to put these together, always switch it back up to where the non-metal is listed last and the metal is listed first. Now, let's combine sodium here with the halogen chlorine. We see that sodium is in column 1 and it has a +1 charge. And we're going to combine this with chlorine, and chlorine is in column 17 and it has a -1 charge. Now the whole job of bonding here is to make sure that these charges, once we have determined what the charge of the element is, when they are bonded together, these charges must equal 0 when we add those together. So you can either look and figure how many chlorines do I need to counter this positive charge over here, or another easy trick is to say, if I take the charge of this ion and I put it down here at the bottom, and take the charge of this ion and put it down here at the bottom, and write sodium 1, chloride 1, then I have my balance out. But since it's a 1, we do not have to write that, so we can get rid of those right here, and this just equals sodium chloride. Okay? So all I end up doing here is just writing sodium chloride, and I have a 0 charge on it, and that would be my answer. Now we're going to combine calcium and phosphorus, okay? And we need to make sure that we get back to where my charges added together are always 0. We look at calcium, it is in the column number 2, and that means everything in column 2 has a 2+ charge. We're going to combine that with phosphorus. And if we look at phosphorus where it sits on the periodic table, we can see it is 3 away from the noble gas column, so that means it can gain 3 electrons, so it forms a -3 charge. Now, just like we talked about a minute ago, I can either figure out how many calciums do I need to add to make this up. Well, if I have 2 phosphoruses, that's going to come up with a -6 charge. And if I have 3 calciums, that's going to come up with a 6+ charge. And if I add those together, then my charges equal 0. So what this means is that I have calcium, 3 of them, and phosphorus, I need 2 of them. And then that would be my balanced ionic bond between calcium and phosphorus. Now we're going to work with a polyatomic ion. And if you do not remember the polyatomic ion, there is a little chemistry video that I have showed you the 8 that we need to memorize, okay? A polyatomic ion is a combination, a covalently bonded combination of nonmetal elements with oxygens in them. But we're going to use magnesium which we see is also in column 2, so it has a 2+ charge, but this time we're going to use the polyatomic sulfate. Now remember, these polyatomic ions, the only way that you can't look at the periodic table and find them, you have a list that you have to memorize. So if you have not memorized this list, then you need to go back and look at that and memorize these polyatomic ions, because it's very important for the mandatory pass exam that's coming up. So sulfate looks like this and has a 2- charge. So once again, how many magnesiums do I need to balance out the charge on this? Well, since the charge is the same, if I add those together, it would equal 0. I do not need any more. So I can just write this as magnesium sulfate. Now, it's a good habit to get into just putting a parenthesis around your polyatomic ion, and that'll become apparent here a little bit later. Now, here's some areas that we can practice, okay? So I'm going to, what you should do is just press pause, write it down, and I'm going to just give you a few seconds between each one of these, and then I will write the answer over here. So go ahead, start now. All right, here's the first one. Sodium has a +1 charge. We're going to add it to iodine, which has a -1 charge. So that's going to give me sodium iodide. Here's the next one. Magnesium, which we already stated has a 2+ charge. We're going to add it to phosphorus, which has a 3- charge. Once again, figure out how many we need, or take the charge and put it at the base of the other one, and it will usually always balance out. So we need Mg3P2. Calcium plus oxygen. Calcium has a 2+ charge. Oxygen has a 2- charge. Those are both going to cancel each other out, so I just write down calcium oxide. Sulfur has a 2- charge. I'm going to add it to potassium, which is in column 1, which has a +1 charge. Now here's one of those tricky deals I was telling you. We've listed the metal in the second one, but we know it has to be first. So when I write this compound, or I name it, it's going to be written as potassium. I need 2 of them to balance out this 1 sulfur. So there's potassium sulfide. Here I've got bromine, -1 charge, strontium, 2+ charge. I got a 2+ here. I got a -1 here. It's going to take 2 of these -1s to balance this out. So I'm going to have to once again put my metal first. Strontium, 2+, bromine. I'm going to need 2 of them. And I have strontium bromide. Now there are lots of places on the web that have practice problems. I also have practice problems on the classroom website. You need to keep practicing this skill, because this is one of the main things you need to know to pass the mandatory pass exam. Remember, chemists try, stay gritty, and never, ever, ever give up.